Hello, friends, and we are back once again with a different problem this time. And we're given that function y is equal to x to the power of minus x squared. And we want to find the derivative of this function using implicit differentiation. So, right, this is how we go about it. So the first thing that we do, we take our function and we apply the logs to both sides. So I'm going to say ln for the natural log. So it's going to be ln y equal to ln x to the power of minus x squared. That's for starters. So now you can see that on the right, we can apply the power rule of logarithms. So this then becomes ln y. So because of the power rule, we bring down the minus x squared. So we bring it down and we can rewrite like this. Good. So what do we see now? We can differentiate the left side implicitly. That's not going to be a problem. That's going to be what? 1 over y and multiplied by y prime. But what you observe here is that we've got a bit of a challenge because this is a product. So we have to apply the product rule of differentiation. So let's do it on the side here. Let's create some space and then try to work out this function, the derivative of the right-hand side. So if we take our, let me use a red pen. So we can take this to be our f, and the ln x can be our g. So then we can come here and say, okay, f is what? F is going to be our minus. So f is minus x squared. So immediately we can work out f prime. So our f prime is what? Our f prime is minus 2x. So our g is what? Our g is ln x. G is ln x. So g prime is very simple. This is going to be 1 over x. Right, so we got f prime and g prime. And our derivative, of course, because we're using the product rule, remember fg plus fg, prime on the f, prime on the g, and then let's substitute. So that'll give us what? Minus 2x. That's minus 2x, which is our f, and our g is ln x, plus, then we come to the f. Our f is minus x squared, and that's our f, and then g prime is 1 over x. So let's simplify this. This becomes minus 2x ln x plus, and the negative becomes negative. And this x here is going to cancel with the 2. So it's going to be minus x. So this is our derivative using the product rule. So we now need to take our answer and bring it to this side. So that means the derivative of the right hand side now becomes minus 2x ln x minus x. So that's where we are now. So I think we are ready to proceed. So we need to make y prime the subject of the equation. So making y prime, that means we multiply the right hand side by y. So then we can say y. But remember, we've got a minus 2x and we've got an ln x minus x. Right. So what do we do here? Before we worry about our y, let's play around with the inside a bit. So let's take it to another step. We're still keeping our y. So now notice we can use the power rule. We can bring the 2 up, and we then remain with negative x. So we remain with negative x there. The 2 is going to go up. Then we now have ln x squared. And we still have our minus x there. And then you can see, because we've got two terms here, we can factor out the x. Let's factor out the x and see what happens. So if we factor out the x, we still have our y there. I should have, okay, let me put the x here for now. I didn't create enough space. I wanted it to be on the left side, but it doesn't matter. So the x is gone. So what's left inside the bracket is ln x squared minus 1. Now the next step, I want to factor out the negative 1. So if I factor out the negative 1, now I get the opportunity to put my x in front of the y, which I wasn't able to do before in the previous step because of space restriction. So now my negative is gone, and I now have a positive ln x squared. Since I'm factoring out the negative, this becomes a positive 1. So remember, this is y prime. Okay, now we are almost good to go. The last step, or shall I say the next step. So we got the negative x here. Now we need to bring in a y. So what is our y equal to? If we go back to the original question, this is our original question. Where is it here? Our original question, the original function is y equal to x to the power minus x squared. So we can substitute the y, and then, so the y becomes what? Is now replaced by x to the power of minus x squared. Good. And then we still have our ln x squared plus 1. Now, obviously, this is x to the power 1, and you should be familiar with the exponent laws. So this becomes negative x. So we can actually say 1 minus x squared. Okay, let's do it like this. 1 minus x squared. We are combining because the bases are the same, so we add the exponent 1 minus x squared, and the bracket remains the same. Nothing has changed there. So remember, this is y prime. We're almost good to go. So in the end, we can also rewrite this. So if we put the minus x squared, let the minus x squared come before the 1. But remember, the 1 is positive, so it will be minus x squared plus 1. And then we remain with our ln x squared plus 1. And therefore, this is our dy dx. That is if we want, if we don't want to write y prime, we can also write dy dx. And this is pretty much the answer. So there you go. Very simple.